said random means dynamic. So it means that you can take any value, whether positive, negative, or zero. It means that Solomon can be anybody's friend, apart from Kiki, but Solomon can be anybody's friend, whether the person is short, tall, everything. So Solomon can be anybody's friend. So just know that.
But that is error now. How can Solomon be anybody's friend? That is a
Friend,
random
Except
variable.
No,
No,
the assumption
everything
is that
except Kiki.
random, meaning it can be anybody, anything. Maybe short, long, anything. That is random. That's exactly what we are saying. Tomorrow, when I remember Solomon, I know.
Does random mean error?
Error is random itself.
Okay,
so
okay.
Like, error is random.
So if Solomon
itself.
can be friend with anybody, that means Solomon is an error. Okay, I get
Solomon,
now.
I'm just in that context. So let's continue the class. So it means
no, those are parts. It's interesting. I'm getting it now. How did you are too serious, you? Okay. I'll keep that. I'll keep that one.
They don't mind the role. Don't mind him. So let's continue. So U is a positive, can assume any value, positive, negative, or zero. So in case they ask us that, list 5 assumptions of OLS. At least tomorrow, we already know that error term is a random real variable. It means once you remember Solomon, at least Solomon is always with his face cap and glasses. Once you remember Solomon, you know that Solomon can either be with face cap, glasses, or what again? Sneakers. He's used to sneakers too. So
or with Kiki.
It can assume. No. Kiki didn't sit with him last Saturday. So, but let's continue. Just know that
is the advantage of the mean.
Let's just know that error term is random. It can assume any value, positive, negative, and zero. So I'm going to call on someone now. Without looking at the screen, I want the person to tell me the first assumption of. So I'll call on Nuruddin. Can you tell me the first assumption of OLS?
Random real variable. Yes, Nuruddin is in the class. Random real variable.
Random real variable. Good.
Yes.
So we should know that.
And okay, I should not continue.
Continue, sir.
You said Samuel can be anybody's friend. I know I will not write this in exam tomorrow, in test tomorrow. But I'm just giving you an example, the way you stated it. So that it means error can take any form, positive, negative, or zero.
Yeah, it's very good. That's very good. So let's move on. Let's move on to the second assumption. Do we all understand? Can I move on?
Yes, please. Yes.
I need response.
It's entering.
Okay.
Yes, it is entering.
So let's go to assumption 2. So assumption 2 states that the zero mean value of disturbance. It means that the expected value of error term must be 0. The expected mean of the error term, the expected value of the error term must be 0, given the value of x. The expected value of random disturbance term is 0. Can you hear me? So I want you guys to look at this equation 6.14. So I will check for. So look at this particular equation. Are we seeing it?
Yes.
I need response.
Yes.
Unless I will continue.
Yes.
Okay. So
yes.
equation, I know that there was a class demand said that wrote all this equation in class. He wrote it on the board and he said, I can just give you this equation and I will tell you that what it means. We all know the way he used to work and he will do his hand. So I can just tell you what it means. So now the way the man say it with his short knicker and the way he used to do his mouth and his laughter. So now let's look at this particular equation. So we have expected value of error term given the value of x must be equal to 0. So it's e into bracket ui slash xi close bracket is equal to 0. So once you see this particular equation, you should know that we are talking about zero mean value of disturbance. It means that the mean, we all know what mean is. You can assume any value. The average must be equal to 0. Mean means average, right? Am I right?
Yes.
Am I right? It shows that the value of u must be equal to 0. The mean of u must be equal to 0. So, and how do we calculate our u? How do we calculate our u? You know our u is equal to y minus y cap, right? But don't let's go into that because we want to study that we just want to study assumptions. So, but it's just like u into brackets umbrella over xylophone is equal to 0. So once you see something like that, we should know that it's talking about the 0 mean value of disturbance. It means given the value of x, the expected value of random term, which is our error term. Random is also our error term, which is equal to u, must be 0. So let me go back to the material. So this means that for each value of x, you may assume various value, some greater than 0 and some smaller than 0. But if we consider all possible values for this given value, they will have average value equal to 0. We know that our error term can assume any value, the way assumption 1 stated it. But the average of all this value must give us 0. So it's just like assumption 1, we are still going to make use of assumption 1 in assumption 2, or in a higher form. So, but you should note that after I calculate all the average of this assumption, it must be equal to 0. So our e into brackets umbrella over x starts from what? X, what's another name that we can give x? What's another name?
Independent variable.
No. I mean to represent, like a representation, something that we are familiar with. So I don't have a name for it. Yeah. So just know that our no, I just need x. Like I said u is umbrella. So x could be what? Okay, we don't know. Let's move on. But our u over x into brackets is equal to 0. So can we move on?
Okay, before you move on to assumption number 3, from what you explained, now let me go back to our friend Solomon. So the implication is that Solomon can carry like 15 guests at the same time. Some might be short, some might be tall, some might have front, some might have back, some might be fair in complexion. Everything, by the time you sum up all of them, by the time you sum up all of them, they all must be 0. Is that what you are saying? So Solomon, you are working for nothing, 0.
So you won't marry any one of them.
0. So you are wasting your time, Solomon. Kiki is there.
I think you are correct with that explanation. I was about to say something like that too. You are very, very correct.
God bless you. Thank you, sir. God bless you.
So, any addition? Do you have any addition? Any addition?
Solomon, no verse, so that you are the case study for tonight. No verse.
Are you guys following me? Are we getting somewhere?
Yes.
Very clear. Very clear.
Flowing.
So, Bukumi Badmus, can you tell us about the second assumption?
The second assumption is talking about zero mean value of disturbance U. So which is saying the total mean value of X and Y should be zero. That means the mean total value should be equal to zero.
Average.
Is that right?
Yes. And thank you so much, Bukumi. And Damilola, can you give us the formula for zero mean of disturbance? Like, can you state it? Is that me in the class? Okay, so
Damilola, speak. Represent your constituency. Damilola, ya or mute and speak. Represent your constituency. Ya speak.
Komade form sleeping go soon.
Okay.
Or mute. Speak. Yes. Speak.
Okay.
Speak.
So for zero mean value of disturbance, that's E into brackets UI over X equals to 0. Right?
Equals to 0. Okay. That's very good. So can we move on? Do anybody have any addition?
Yeah, my only addition is that E stand for expected, Abi. So expected of U divided by X is equal to 0, correct? That E starts from expected.
It's just like all those summation that Laura used to write on the board that is not clear. I'm so sorry to use that. So let's continue. So we all know our assumption 1. We know our assumption 2. We are still going back to it. So, but let's move on to assumption 3. So we have our homoscedasticity or equal variance of U. So the other meaning for homoscedasticity is equal variance. Our homo means equal, and our skedasticity means variance or spread. It actually means spread. So it's like equal spread, equal variance. So let's read. It said, given the value of X, the value of UI is the same for all observation. The conditional variance. Can someone tell me the meaning of variance? Can someone tell me the meaning of variance? Okay, so let's still move on. The conditional variance of U are identical or constant.
You won't tell us. Me.
Please don't let us move on. No, don't let us move on.
Okay, what's the meaning of variance?
We don't know it now.
I'm not telling you.
Olani test do.
I'm not telling you. What's the meaning of variance?
Today is not day of statistics.
So can you tell us the meaning of variance?
I think variance is a deviation from the actual value of something, or maybe the difference.
I actually need a layman meaning, like something that we are used to.
I think variance has to do with exactly.
Deviation from what?
From the standard. Or from the expectation.
From the expectation. That's still very, very, but okay. The man said something in class. He said variable with the same characteristics should move together. So that is the way X is going to deviate from Y. The value of X should move together. They should move on the same line. They should be the same. They should have equal routine. Like should have equal space. Let me just use that. But that's not the actual meaning. But you guys all understand what I mean. So it's just like they should have like they should move together. The deviation, it shouldn't be something far away, like one will be down, one will be low. They should move together. We are all okay for purpose. We want to achieve the best in our result. We want to come out with at least good grade. Have our certificate. That's the major thing. Have our certificate, then get better in life. So we are moving, like we are trying to achieve a particular goal. So it's like let's just move in the same direction. So what homoscedasticity is saying that this for giving the value of x, the variance of u should be the same. Like the way they deviate.
Hello, hold on. Wala Deo. There is Professor Lowe here. Who is using Prof Lowe here? I can say one person called Prof Lowe.
Every the person, please. Everything.
Oh my God.
No, we can't take the person. Every the person.
Please, Gafaro.
Okay.
Every the person.
You can now impersonate.
It's Gafaro.
The person said it's Gafaro.
It's true.
Gafaro, do you want to come our auditors here? Do you want to come our auditors? Do you want to come our auditors? Okay, so let's continue. So they should move in the same direction. Like the deviation should be the same thing. So that's for homoscedasticity. Equal spread. Sorry, I want to see what I jotted down here. So the above indicate that variance, like variable with the same characteristic, should move together. That means the above indicate that the variance of y of y population should move is constant. So it's in our notes. I don't know if that is there, but let me just go back to my notes, to our notes. So that's just what homoscedasticity is. So let's get familiar with the formula. They didn't really specify, they just write all these terms in the notes. But basically, for homoscedasticity, this is the formula. This is the formula for homoscedasticity. Variance into VAR into brackets UI over XI is equal to standard deviation square. Am I right? This particular symbol means what? Can someone tell me?
Standard deviation square. You are right.
Standard deviation square. So how do we get familiar with this?
Sigma square. That's what we call it.
Okay, sigma.
Sigma. That is like sigma.
Okay, sigma square, right? So VAR, like variance. VAR means variance. UI over XI into brackets is equal to sigma square. So, but for heteroscedasticity, we know homoscedasticity is something that has equal variance, like an observation that have equal variance. They have equal deviations. But for heteroscedasticity, when it is unequal, when the variance is unequal, like the way they move, they just move anyhow, like they are not together. Let me use a common example. Let's say our class rep and our assistant. It's not a common example. It could happen anywhere. I'm so sorry. I'm not offending anybody. Okay.
Please continue. I'm understanding it.
Okay, let's say now our governor and our assistant governor. Our governor said, you guys have to do this. Then our assistant governor said, no, you guys, you will not do this. And they were like, who told you guys to do this? We're like, go and meet Dima. And Dima was like, Dima is a soldier. We all know he's a soldier. Dima, I'm sorry, but you are a soldier, Sha. You know that Dima is a soldier. So, do you know
you are
and he
right.
said, and he said, you won't do this. So they are not moving in the same direction. If they are not moving in the same direction, the team will be divided, right? But at least we appreciate the work they are doing. They are really doing well. So that's another thing. So now, so to bring it into homoscedasticity and heteroscedasticity, so we know homo is equal. The skedasticity means spread, while hetero is unequal, and it means and skedasticity means equal. That means homoscedasticity is equal variance of you, while heteroscedasticity is unequal variance, unequal direction. So looking at this first formula, we saw that this first formula did not have I at the bottom. Sorry. So for this one, it just have sigma squared. Why this one have sigma square I? So now variance into brackets ui slash xi is equal to sigma square. That's for homoscedasticity. For heteroscedasticity, the only difference is the I at the bottom here. That's the only difference for assumption. That is assumption 3. Are we clear? Can I call on someone to summarize this assumption 3 for us? So I think I can see Professor. No, don't let me call Professor Lore. So that let me call Babatunde. Babatunde, please, can you summarize assumption 3 for us?
Okay, can you hear me?
Yes, I can hear you.
All right. Yes, we can hear you.
Homoscedasticity or equal variance. So my understanding is that homo has to do with something that is equal, and scarcity measures variance. And also you explained the meaning of variance, which has to do with deviation from standard. Then going by the interpretation of the formula that we have, the one who talks about the one which explains that variance. Hold on, I want to, because there's a way you actually define the one of assumption 2, which really makes sense to me. So in that way, I would love to define the first equation under assumption 3. So which says variance of the error term given the value of x is equals to sigma square. Exactly. Yes. So why the second one says variance variance of the error term given the value of x1 is equals to standard deviation
sigma square
right?
I.
Okay, sigma square I. Right. Thank you.
Okay, so let's just look over that particular I'm so sorry for all this diverting, but it's necessary. So for homo, we can see the formula. Let me change the color. Oh, sorry. I want to try and change the color of this. Okay, let's move on. Sorry, I did this at work, but let's move on. So we can see this.
Sorry for me.
When you are
sorry. This your U is not squared. I think the U is squared now. This your U in this formula is not squared.
Okay, let me go back. Sorry. Let me go back.
Go back to the formula. The U is squared. Okay.
No, the U is not square now.
See, this the U is not square. I don't know.
They were expressing it here. So, but this is the standard formula. Do you understand? They express it here. That is why it is squared. It's like when you solve this variance of U given the value of x, it will be equal to the expected into brackets U minus expected U was it U slash x is equal to, they now squared it. So after they squared it, it will give you this standard this sigma square. Do you understand? It's like this one. Let me try and copy it out.
No need. Let me just explain to Mr. Alabi. Mr. Alabi, the initial formula given, that one is not required. What you need is the final answer. So for this final answer now, it is simply your variance into u divided by x1 is equal to sigma squared. That's all you need. That's your final. How they arrive at it, those are the breakdown where you see your u squared. But the final one is your variance is equal to u subscript 1 divided by x subscript 1, then it's equal to sigma squared. I think that's just what you need, sir.
Can we move on?
Okay, thank you. I'm okay.
Yeah,
then another thing I want to say is that sorry, that your MS Word file that you are sharing, is it possible for you to share that MS file with us after this class? Because someone like me, I want to cram everything that is here. Yeah, it's summarized. Thank you.
I will. Thank you. So let's move on to assumption 4. Please, are we clear with assumption 3? So let's move on. So my connection is okay. Can you guys hear me?
Yes, we can.
Yes,
now. We can hear
Yes,
you.
yes, we can. Yes,
Okay.
we can.
So you know why they say that error term has a normal distribution? Normal. We all know what normal is. Like what can I refer to? I think something happened and the one was like, Fumi, you should have shared this thing in Excel. And the next thing he was after sharing, he said, Dada. That means my head is there, Abby. So our friend did something that really made us proud. We said, your head is there, like you behave like a normal human being. So in the class, the man said that histogram is used to check normal distribution. Histogram is used to check normal distribution. Let's note that. Histogram is used to check normal distribution. One of his classes, he mentioned that. So, and let's see how was it our error term. It has a normal distribution. So let's see the quality of that normal distribution. So for assumption 4, is the combination of assumption 2 and 3, basically. So let's just read out something here. It said have a bell-shaped symmetric distribution about their zero mean. So I'm coming. I think I jot down something on it. So so it said that the value of u have bell-shaped symmetric distribution about the zero mean, still the same thing. U is normal distribution with zero mean and constant variance. That means for our U to have a normal distribution, it has to have a zero mean and it must have a constant variance. Sorry, excuse me. That means it must have. Can I get water? So that means it must have zero mean and it must have a constant variance. So now we should all know that our U, normally the assumption is that, I'm sorry everyone, so normally the assumption of U is that it must have a zero mean, and we know what zero mean is. Expectation of y given the value of x is equal to 0. That's e into brackets y slash x must be equal to 0. So U is normal because it has zero mean and constant variance. Like it has zero mean and homoscedasticity, equal variance, equal spread. Like twins now, twins, they will wear everything equal. Everything must be, even though they are not, they don't have the same stature, but they move. Some twins move the same way. We are all watching BB Naija now. We have Wanya and Andy. They wear virtually the same thing. So for you to be normally distributed, can you hear me?
You said we all watch BB Naija. Some of us don't watch it.
Okay, sorry. For those people that watch BB Naija. So our U is normally distributed with zero mean and constant
generalization.
So we can see our U. Our U now, there is one scholar. I don't know how to say this particular dash, but just know that there is
Sorry,
one
please,
dash.
Are you sharing your screen? I can't. I don't know if I'm the only one.
No, it's your network, Oga. You can.
Right.
Yes, exit and join. It's your network.
Can you guys see my screen?
All right.
So we can see that our U has one scallop in like that. Then N means normal distribution. Into brackets, we all know what our zero mean of disturbance means, which is equal to 0. And we all know what our homoscedasticity is, which is equal to sigma square into brackets. So we all know this particular formula. Let's just picture it in our mind. Like, let's say 1 second, close your eyes and open it. You can see, once you see this formula, you should know that this formula this formula means that U has a normal distribution. U has a normal distribution. U has a normal distribution. So I have my prof in the house. So let me call on someone to, please, are we clear? Before I call someone, are we clear with what I explained?
Yes.
You guys are clear with what I explained, right? Okay, so please, who is in the class? I think I can see Anu. Anu, baby, can you tell us what our U is as a normal distribution? And I told you, I want you guys to note this, that histogram is used to check normal distribution. Please, let's note that. So, Anu, please, can you tell us what our U means? It has a normal distribution. Can you explain that assumption for us?
Okay, good evening, everybody. So, based on your explanation, assumption 4 is like a combination of assumption 2 and assumption 3. And to say that the mean of the variance that will give us 0, it means that you must have a normal distribution with a sigma square.
Okay, thank you so much. So can someone state that formula in his own way, like maybe another way? Let us understand it, that formula of normal distribution. Mr. Oladiro. Oh yeah, let's hear from you.
I'm not following, ma.
Governor, why are you not following?
Not is so.
No, ma. I'm doing something else here.
Okay, so I'm coming. I need to get a name. I'm coming now. So we have Abisola Afolayan. Can we hear from you? Assumption 3. How best can we explain it? Okay, we have Istrefa Ray. Please, can you explain assumption 4 for us? The formula. Just state the formula. Okay, so
good evening.
Okay.
Sorry. Yeah.
Okay.
Yes, I'm not sure I can, but okay. My understanding of the formula is that the error term is normal distribution with 0 mean and constant variance. That is with the assumption.
Variance.
Yep. So with assumption 2 and 3, that requires that the error mean must be 0, like summation of the error mean. No, sorry, not distance summation. Error mean must be 0, and then second one of the equal spread, that the error term of all observations too must be the same. So that's just
That's it. Okay. Thank you. Do anybody have any addition? Any addition? Okay. That's all for assumption 4. Let's get familiar with the formulas so that when the man, the question can come in 2 ways. If he's not going to set outside his assumption, the man may just write the formula on the board and he may ask us to state what it means. So he may write state the formula for normal distribution on the board. So we should all get familiar with that formula. Like, it must have the combination of zero mean and homoscedasticity, that is constant variance, which is our sigma square. So let's move on. Let's move on to assumption 5. No autocorrelation between the disturbance. Yesterday, Oladiran asked a question. He said we should try and explain what this xi and xj means. What xi and xj means. So I'll still come back to that. So let's move on. It said given any two x values, xi and xj, the correlation between any two ui, let's say ui is for si, uj is for xj, symbolically, covariance ui, uj slash xi, sj is equal to, they defined it. After they defined it, they got sorry, I was using my hand too. So they got this particular equation. They got this particular one. So after solving, they got this. So now that means COV into brackets UI, uj slash xi, sj must be equal to 0. Abi? Or another way, you can write it like this: expectation of ui slash xi into brackets uj slash sj must be equal to 0, where ij are two different observations and where curve means covariance. In other words, this 6.15, let me see, what's the formula? 6.15. So 6.15, look at this formula. This should be the formula for 6.15. Well, let's move on. Posted that the disturbance u, I, and uj, the random time of different observation, are independent, are uncorrelated, or equal to 0. Technically, this assumption is no serial correlation or no autocorrelation. It means that we have two error terms: error Solomon and error way again. Let me just say error Solomon and error who can I say so that the person will not get offended? Error anything, sha. Solomon is my guy. So error Kayode, let me use Kayode. So error Solomon and error error Solomon and error Kayode, they must not be equal to 0. You cannot, they must be equal to 0. That means they must not be equal. You can't say that, oh, Kayode is married. You can't say that the babe where Solomon like, who is the other person I can use? The babe where Solomon like, let me use Chibueze. Chibueze is also my friend that I know I'm familiar with. I can apologize tomorrow. So the babe where Solomon like will be the same babe.
Use BBM. You don't need any apology. Use BBM.
The same babe where Solomon go like is the same babe Chibueze go like. They cannot be equal. Like, you just say that the two error term must not be equal, given two values of x. So now let's say that x have 2. We're all familiar with that equation. I showed you PRF equation, which is y equals to beta 0. Let me go back to that equation. Y is equal to beta 1 plus beta 2 x1 plus ui. let's say now we have this particular equation. When we put x, the value for xi here, and we collect like times. Yes?
For me, sorry.
Yes, sir.
I was distracted for a while. You are not sharing, Abi?
I am. Can anyone view my screen?
God, your network. We can see your screen. Don't mind him. She should go and change his network. Sure. Exit and join again.
Okay.
Exit and rejoin.
We have two different values of x. Let's say 2 and 3. So now for x is when x is 2, let's say that one is I. When x is 3, that one is for j. So when we input x into this, the value of x, which is 2, into this equation, and let's say that this equation beta 1, beta 2. Okay, let me just type it. Sorry, I think I should type that. Well, okay, let me take this water. Let's say our y. Sorry. Our y is equal to, our y is equal to, let's say our beta 1 is 2 plus 3 times our beta 2 is 3. Let's say our x1 is 1, for instance, times, where's our times? Times 1 plus 3. Let's say our error time is 3. Our error time is not 3. No. Let's say the value of our y here is 6. The value of our y is 6. So our error term 1, let's say our u1, let's say our ui. So now after solving this particular equation, yes? Yes, sir.
Can you use your mouse to point to where you are?
Okay, I'm here. Can you see me? I'm typing. Can you see where I am?
You are typing.
Yes. Can you see where I am now? Please, can you guys see I'm doing?
I'm only seeing your the Word document. I'm not seeing any typing.
I'm actually typing.
He's typing under the assumption 3 now.
Can you guys see what I'm doing now?
He's typing under the document.
You are typing under the assumption 3.
Yeah, don't mind him. The guy don't sleep. He's don't sleep.
So let's say after solving this particular equation. After solving this particular equation, yeah. Are you guys with me?
Continue, Joe.
So after solving this particular equation, so 6 will be equal to 5 plus u1. So when you collect the like times, u1 will be equal to 1. So that means our ui is equal to 1. Let's say our u1 is equal to 1. Let's say the value for our x, another value for x is let's pick 2. Another value for x is 2. So when we put it here and collect like times, the value will be the value of uj. Let me just make uj 2. Sorry, uj will be equal to 2. Okay, will be equal to 0. I'm just trying to use that using this particular equation. So it shows that for assumption 5, we are seeing assumption 5. For assumption 5, when we give 2 different values of x, our ui, as we can see when we put numbers, our u1 was not equal to U2, was not equal to U2. That means our UI can never be equal to UJ. That is for assumption 5. So, and they must not be related. So let me go back to my Word document. Let me see what I jot down on that. So they cannot be related. That means giving any two values of x, x1 and xj, the correlation between any two errors, which is error for I and error for j, is 0. They are not related. More like they are not related at all. That is what it means. It means that they cannot be related. So then we have the formula is expectation of ui over xi into brackets uj slash xj is equal to 0. We can see it here. Expectation of into brackets ui slash xi into brackets uj slash xj is equal to 0. Can we move on? Do you have any addition? Please, any addition? Are you guys with me?
Yes, please consider.
Struggle behind you, ma.
Okay, so let's move on to assumption 6. I know it's 10 already, so I want us to round up before 10:30 so that we can revise it together from the top again. So I won't be calling on anybody this time around. So let's move on to assumption 6. We have 0 covariance between ui and xi. Is it 0 covariance between ui and xi, or expectation of ui given the value of xi is equal to 0. So it's not actually giving the value of xi. The value x, what it's saying is that they don't vary together at all. They should not tend towards each other. So, but I will still read out something to us. So there is a difference if you look at this particular, if we look at this particular equation. This is the equation for assumption 6. If we look at this particular equation, you will notice that it's similar to what we have in assumption 2. Am I right? Am I right?
Yes, you are right. You are right.
You can see that it's similar to what we have in assumption 2, but it doesn't have slash. That is the difference. It doesn't have slash, but it's similar to what we have in assumption 2. So when we see this kind of formula tomorrow, we know that our expectation into brackets ui xi is equal to 0. For 0 covariance, it doesn't have slash, but for 0 mean, it has slash in the middle. For 0, I repeat again, for 0 covariance, it doesn't have slash, but for 0 mean, it has slash. Can I move on? So let me go back to that, my little play something. So for assumption 6, 0 covariance between ui and xi. So assumption 6 states that disturbance u, we all know that disturbance is also the same thing as error, which is denoted as u. And explanatory variable are uncorrelated. They don't relate at all. The rationale for this assumption is as follows. When we express we should know the formula for the equation for PRF by now. We know that our PRF is y is equal to beta 1 plus beta 2, but we are not going there. So let me just move on. We are focusing on assumption alone. We assume that x and u, which may represent the influence of all omitted variable, have separate influence on y. So let me start my explanation from here. So now, why this assumption state that for u and I, there is zero covariance. They don't relate at all. Like there is not even minute. There is nothing called minute relationship. They don't relate. Like it's just me. Let me say I'm Yoruba. Me and Ebere, for instance, we don't relate because by tribe we don't relate at all. I'm Yoruba. She is Igbo. I don't know if she is Igbo, but let's say she's Igbo. So we don't relate at all. So now it means that the influence, let's say now for X, we know that consumption is a function of income. Consumption can be a function of your taste. But what zero covariance means is that taste will have its own influence on consumption. We are going to look at it differently. And why our income, which is the major independent variable for determinants for consumption, we have its own separate influence on Y. So that's the meaning of that's the meaning of the zero covariance. Like my explanatory variables, and you know that our U represents all omitted variables. We can't be saying that, oh, consumption is a function of income, a function of taste, a function of influence, like influence from friend. Because my friend is consuming this, let me also consume this. Because this thing is because this thing is raining, let me also buy it. Because my friend is wearing this nice suit, let me also get it from the market. No, it means that this particular explanatory variable, they have their own zero influence on, they explain our independent variables separately. So, and we can just read up all this if X is positive related, blah blah blah. So we can read it. So it is difficult to isolate the influence of X and U on Y. You know, assuming they are related, we can decide that let's just consider X alone. Let's consider U, because they will give us similar results. But no, we have to consider both of them differently as separate variables in order to consider the influence they have on Y. So we can see the formula here. So in case we see something like this, we know that for zero mean, it has slash. But for zero covariance, it doesn't have slash. Please, let's note this. So let's move on. We are almost done with the major part of the notes. So let's move on. Please, are we clear? Are you guys with me? Are you guys with me?
Yes.
Yes, we are with you.
Okay, so let's move on. Let's move on to, and then the man said something in class. He said when the variable knows error term, let me say when X simultaneous equation, he mentioned something like that. I jotted it in my notes. So he said when the variable know about the error term, like when X is aware of other variables, like the error term, like the variable of the error term, when X is aware of it, the equation becomes simultaneous equation. So there must not be correlation between X and error term at all. Relate, and we should just get familiar with the equation. So let's move on to assumption 8. So for assumption 7, sorry. Assumption 7 states that the explanatory variable are measured without error. The explanatory variable. Please, who can tell me the meaning of explanatory variable?
I think explanatory variable are the same things as regressors. That is the independent variable that you use to ascertain or measure or estimate the dependent variables.
Okay, so who can tell me the explanatory variable in this equation? The equation of PRF. What's the explanatory variable? Please, I want to hear a female voice now. What I want. Okay.
That is X1.
X1. Okay, so we all know what explanatory variable is in this equation. So let's move on. So he said that the explanatory variable are measured without error. They are measured without error. But he told us in class, he said that our assumption 7 is not really important, but it's still part of the assumption of OLS. So he said that, so you absorb the influence of omitted variables and possibly errors of measurement. So we can read up that, but you should all know that our explanatory variables are measured without error. So let's move on. So our assumption 8, there is no perfect collinearity. Sorry about that. There is no perfect multicollinearity. So what can we say about that? Can someone explain? There is no perfect multicollinearity. Can someone explain that? I don't want to call names. Okay, so let me call someone. Let me call one of my professors. So 280, please, I want to hear from you. 280. Or Professor 280. Anyone? Let me hear from you. Are you guys with me?
Yes, we are with you.
Yes. 280 seems to be sleeping.
Okay.
So Kazim, can you explain?
No, 280 want to speak now. Let 280 speak.
Okay, 280. Please, let's have you. Oh, I think he's sleeping. So Kazim, can we have you? Can you explain the assumption 8 for us?
Yeah, okay. What assumption 8 is talking about is that there is no perfect collinearity. That is, the two variables cannot be multicollinearity, that the two variables cannot be perfectly correlated, that there will surely be some differences between the two variables. It's just like a mother that gives birth to twins. You can't say because somebody has given birth to twins that they are all expected to behave exactly the same way. There will be some slight difference in terms of their behavior. So that's how I understand this one. Because when we say linearity, multicollinearity, linearity means relationship between two variables. So we're not saying that there can never be any perfect multicollinearity, meaning when you have two or more variables, the two or more variables cannot be perfectly correlated or related. There will always be some form of differences. All right. I hope I explained very well in my own way.
Okay, thank you. So I think the man used this to explain in class. He said that when a guy is he wants to settle and he has like 5 babes. So you can't expect those 5 babes to behave the same way. They may have similar characteristics, right? But there will still be some differences. Like there will still be a bit, like this one may not, this one may like red, for instance. The other one may not like red. One of them may like green and none of them like green. I'm just using colors as example. So there is no perfect relationship. So we know that between husband and wife, at least my own parents, I can use them as example. You can't say that there is really a perfect, let's say, there are some things that your mom will like that your dad will not like. and there's some things your dad will like that your mom may not really like, but because this person is my husband, let me just obey that person. So there is no perfect linear relationship. So let's go to assumption 9. So this assumption 9, you know, the our first note, we talked about the steps. Sorry, we talked about steps of step that is used to carry steps in econometric analysis, and one of the assumptions says specification of data. So what this means is that our regression model must be correctly specified. Like, we must specify it very well. For instance, when we are doing our projects, there are some of our models that we must make sure that we must specify it correctly. So in order to avoid error, there must not be error, no specification bias or error in model used in empirical analysis. So we can read up that. Then for assumption 10, he said micro variables should be correctly aggregated. Usually variable x and y are aggregated variable. That means our x and y, they are aggregated variables. Like when we are drawing our regression, when they ask us to look for beta 1, beta 2, beta 3, you know, when we are doing that, when we are aggregating our figures, like finding the sum, aggregate means sum. When we are summing it, we must do it correctly. We must apply correct equations to solve them. We must apply correct equations to solve them. So he said that it is assumed that appropriate aggregation procedures must be adopted in compiling our aggregate variables. So we have our assumption 1. Let's move down to our assumption 1. Our U is random real variable. Let's know that. Then for assumption 2. Yes, sir.
For me.
Yes, sir.
Please. When stating the assumption, is it a must we arrange it in the order it was arranged in the book?
Is the way it comes though. For me, I don't know. I don't really know how economics lecturers are in. Sometimes you can't predict them. They are error. Sorry, I have to use that. But their economics lecturers have their own different way. They are error. I mean it in a good way, not in a bad way. That they have their own different way of marking. They mark unnecessary steps. But for me, the way I remember, that is the way I'm going to write it. Though. I'm not going to. It's not. I don't think it's compulsory.
I think it would be too petty for them to start asking us to list it exactly. It was arranged there. What matters most is how to apply it. I think the man will. I think based on my own what I've understand about that man, he will just write any of this formula and ask us to prove the assumption. So you must know any of the equation. It will just give us like this EU divided by X is equal to 0. You can just ask, prove this, because he has done something like that for us in the class before, if you remember. He will just write this equation on the board and tell us to prove the assumption. So you must understand the assumption before you can be able to prove the equation.
So how do you prove?
How you prove is just to explain now. When you know you explain.
Proof means
explanation, you explain. Explain the equation, that's all. So once you see the equation, you will just like what I'm doing tonight now till tomorrow is all the equation. I'm going to write them somewhere. Then I'll start explaining the assumption one by one. So anything that works for you, just do what works for you best. But I'm sure that it is those equations that he will write for us, and he will want us to explain the assumption. So I'm stopping the recording now. So he will just ask us to work on the assumption. That is all. So that's what we do. But I don't think it will be too petty to say that we should be cramming the steps.